Now let's just see what the demo environments look like. So we have a front end chat UI. So this is our UI that is written in Streamline. And we also have Envoy proxy to connect with the UI. So whenever you send a request, the request will be sent into the Envoy proxy. Behind Envoy proxy, there's Envoy xproc, which is basically our semantic router. Within this semantic router, we have this fine-tuned burst model. That's where just classify what's the prompts category, and then using that as a selection to pick up the best models for the rest inference. We also have a semantic cache, which is basically just a cache similar request responses. So the next time, if you have something similar to ask for, that if that similarity above certain thresholds, the previously cached response will be returned instead of getting from the models again. Within this setup, we have three models that are in our inference engine. The first one is a Llama 3 27B model, and then there's a Mistral small model, and also we have a Fine 4 model. We have previously benchmarked each of the models in a very small data set based on MLU Pro. So the overall idea is that we want to get some information about the model's accuracy in different categories. So this is what we see in the overall in the overall benchmark results. We also benchmarked our own model selection, which you see here in the auto category. So if you are looking at the overall accuracy, I'm just highlighting it here. So if you look at the overall accuracy, the auto model selection is outperforming both all these three underlying models, right? So the benchmark result is used in our configuration. We basically have leaderboard information in our configuration. So whenever we classify a prompt, we just pick the models based on their rankings from this leaderboard information. All right, without further ado, let's just starting with the demo. So the first demo of prompts come from the MLU Pro in the category of economics. You can find this question in the MLU benchmark results. Let's just see if that is something we can find out. And you can also find the results in this benchmark in this from there, right? Okay, so as we are looking at a question, so you basically can guess what you need from the testing rows in the MLU Pro dataset, and then we're using that in our testing. So remember, the correct answer is E. So whenever we see models doing the right thing, it will just produce answer E. So first of all, we are just using the semantic router, which we are just using the model auto. Auto means that we pick up the best models that is excelling in that category. Let's push the models to work. So the first time the prompt is being processed, it's going to the backend model, and it take a while for the results to come back. And we will see once we have a semantic cache, the second round of the same query or similar queries will be much faster. Okay, so we get the answer back in 24 seconds. So the answer is E. It's matched with what we get from the benchmark results. Oops. Right. Let's just run these queries again. So it's in the second time, so it takes 0.18 seconds. So because that's come from the cache, even though this is the exact match, we can also see if you are running similar tests, if the prompts does not have to be identical, they just need to be close to each other semantically and to match with the results. Okay, let's just run the queries using a different model, underlying model explicitly. So we see here in economics, some models are doing better than the other one. So the chances are we get results from a JAMA 3. Let's see if that's the case. So we have a dashboard here, which basically just tells you what is going on in the backend. So we see we have a one conversion from auto model to the JAMA 3 model, which means that the router actually pick up the right models based on the readable results and the classification, obviously. If we are running the results on a different model, so let's just say we are using the Mistral small model. Let's see what could be the results. And let's just copy the question again. So remember the correct answer is E. Again, this will take a while because the actual processing on the models will take a few seconds. Okay, so Mistral actually gets a different answer. It's a none of the above, which is not correct based on the MLU datasets. So this just gives you some overview. That's why picking up the right model for the expected domains makes a lot of sense to improve the model accuracy. All right, that's it's the end for the demo.